All right, so we're going to be looking at the Hess's law and the overall reaction. Let's make this happen. Remember that the overall is going to be somehow set apart from the other reactions. Like there'll be a list, but the overall might be above it or below it, but it'll be a little separated. It should be called an overall reaction also. So what you want to do is focus on the overall reaction. Start looking at the first reactant, and you're going to go left to right twice. The first time that you do it, you're going to be looking at the, like you're going to be starting here and you're going to look for a match in the reactants and see if they're in the right place. And that also is in the products too. It's just wherever it happens to be. See if it's the right place. You want to ignore if something is in two reactions. So like this oxygen's in two, so don't even mess with the oxygen. It's going to fix itself. And then the second time is you're going to fix coefficients. Don't try to do them both at the same time when you first are learning this because it is confusing. But once you get it a few times, then you'll be able to do it. All right, so first things first, we have a sulfur. Let's find the matching sulfur in the equations below. Here it is. So you ask yourself, is that then in the right place? Yeah, so that's going to mean that that first reaction is good. If you keep looking, there's like an oxygen, but honestly the oxygen, again, it's in several places. Don't worry about it if it's in several places. So then we're going to work our way to this other side and we're going to find where this one is. So if we look down here, this is where this one is. And notice it's in the wrong position. Over here, it's a product, and over here, it's a reactant. So what we're allowed to do is flip the reaction. So I'm going to make a copy of this going downwards. That's one. But then this one, I'm going to put this on the left. I'm going to still have my arrow. I can just draw that. And then this part is going to be on the right. So I've just flipped it. And then don't forget, when you do that, your H has to also flip. So this is now positive. So we are still comparing to this overall reaction right here. But we are no longer looking at these ones. You can get away without rewriting everything, but I wouldn't until, again, you're confident this and you've done it several times. So we've done our first step. Now our next one is to fix the coefficients. So now we're actually looking at the front numbers. So in front, is it the same? And you say, yeah, it's the same. Then we'll look at the oxygen, but you can't look at the oxygen because it appears in several equations. It'll fix itself. Then let's look in front of the SO2 here. Oh, look, this is a 2. So let's change it. You're allowed to either multiply or divide. And sometimes what's easier to think of is like multiplying by a fraction. So this is, you can say you're dividing everything by 2, or you can say you're multiplying everything by 1/2. It's the same thing. I'll do it by 2 here, by 2 here, and this is an understood 1, and that's there. So I have to also do this to my H of my reaction. Alrighty, now, if I've gone through both of those checks, fixed all my coefficients, then what that means is I can combine the reactions. And what I'm going to try to do is see if they match this. So here's our combining rules. By the way, I'm going to change this to 1 because that's going to be easier to see, and I'm going to change this one to 1 so that's easier to see. And I'm going to take off the colors so I'm not distracted by the colors. All right. So now, as we are looking at things, we have something that appears on both sides, and that something can cancel. So right here, SO3 is on both sides. And notice it's even, like there's an understood 1 for both of them. So that just cancels. And then if we want to combine things, if you'll notice, I actually have an oxygen hanging out over here, and I have an oxygen over here. So they don't do an even cancel, because if you look at those coefficients, they don't do an equal cancel. But you might be able to see it's like the 3/2 loses a half. Maybe you can see that. And so that would make 2/2, which we know is the same thing as 1. So this will go away, and it'll just be an understood 1 right there when I cross this one out. So overall, I have S solid plus O2 goes to SO2. Now, if it bothered you doing it that way, like across the reactions, you could have also done this. You could have written down everything plus 3/2 oxygen gas plus SO3 gas goes to SO3 gas plus SO2 gas. You could have written it all out like that, and then it's easier to see like when they're on the same reaction. So like that cancels with that. Those are our SO3s. And, oh, I left off my oxygen. And then you can see this kind of like halfway cancels. That cancels with that. Sorry, makes that a 2. Either way works. And that's our overall. As long as we're good on our overall, then what we're going to do are combine our H values. So we'll have negative 395.2 plus, and we're not subtracting, we're adding these together, 198.2. So 395.2, and that's a negative. Yeah. And then we're going to add 198 times 2. Oh, it's 0.2, sorry. 198.2 divided by 2. That's it right there. I just didn't write it down. I didn't carry it down from there. So that total is going to be 296.1 kilojoules per mole.